let's start with enumerate because that is super important. So before we start, what does enumerate give you? Do you remember? Enumerate gives you index along with the value. So if I have a list here, list is equal to, it's going to be a small one, so I guess I'll just type it here. I did it again, so what can we do? Delete list. Now you can use the list function properly. So this is our list one. And then if you have something like for I in enumerate of list one, print I. So it gives you a tuple. Here is the index 0, 1, 2, and here are the values 1, 2, 3, 4. So you can just put I comma j. So I is the index, j is the value. So we will take some problems later in Python and we can see how this enumerate is very useful. So just remember, if you can unpack it like this, and I has all the indexes while j now has all the values, but if it's just a single one, it's a tuple of both the index and the values. So that is enumerate. Coming on to list comprehension. List comprehension is similar to making a list. So it just helps you make a list using list comprehension. So starting off with a simple example. For x, for I in range n, oh, I for I in range 10 and list 1. So these two need to be same, and this is just a simple example. It's similar to our just typing list of range, but you don't need the list function, just brackets here and I for I in range. But you might think that using the range here is more efficient. Yeah, but only for this case. What if you need an if condition? If x is greater than, we only have I, so I is greater than 5. Now you can see it has even filtered it out. So if you give if here, if after the follow, if condition comes. So if I is greater than 5, then it will be added to the list. You can give anything you like I lesser than 5, I not equal to, let's put a list of exclusion 5, 6, 7. And this prints you 5, 6, 7. Why would that be? Because it checks for a list of 5, 6, 7. Now I'm going to check individual elements. So for something like that, I in 5, 6, 7, then it prints as true. But if you give not, then it won't give you 5, 6, 7. So I not equal to for 5, 6, 7 would be checking for I not equal to the list itself. I not equal to this whole list. So that is what the not equal to and in have in difference. So in takes it individually, while not equal to takes it as a whole. So if I in 5, 6, 7, that means it's true. But since we want without the 5, 6, 7, we go not in. But what if you want an else condition? And if you want the if else statements, you put the if here, but it only works if there's an else also. So let's give you an example. I greater than 5, it gives you an error because if it's going to be put here, it needs else. So what can we give in the else? In the else, we can give what must be coming if there is this thing right here is false. Not odd, let's give n. So for all of this, it's going to give you n, because if this statement is false, goes to that spot. And till 5, it's false, so it gives you n. Also, you can have something like, we have learned about the percentage symbol. I percentage 2 means the remainder, this gives you the remainder. And if the remainder is 0, it's an even number. 4 by 2 gives the remainder of 0. 6 by 2 also gives 0. So if it's an odd number like 5 by 2, it'll give you the remainder 1. So else odd. As you can see now, this condition doesn't satisfy for the odd numbers, and hence it goes to the else spot and it gives you odd here instead. So other than this, apart from this if else, we can also have something like a function. So if this is true, we can have string I. Now everything here is converted to a string. Other way you can use this is, let's have a list of strings. Up, at, cat, and hamster. Remember that instead of this, wait, let's make this proper first. So let's remove the if statement for now. And let's type I dot upper. So now each of them is in uppercase. Instead of this, we can also have it like a, any variable name, and a is equal to this. So for each of this, it runs this function right here. We can have title case. So the first letter here is capitalized, or lowercase means it's going to be the same anyways. So that's how you can even implement functions inside. Or we can just print the first letters of all these words. I of 0, isn't that right in indexing? Do you give it as 1? No, indexing is from 0. So now you have the first letters. I want the last letter, but it's all different. This is 3, so giving it an index of 2 wouldn't give for hamster. We have learned this. Let's give -1 for the last ones. PTTR. PTTR. So that's how you use list comprehension. And also, let's take a complex case. A is equal to, A is just the list. So X, comma, Y. For X in Xn, let's make this a tuple first. For X in range 3, or Y in range 3. And A. So what it gives us, it takes these two loops, and these loops are nowhere combined, so these two are separate. So you get 0, 0, 0, 1, 0, 2, 1, 0, 1, 1. So this is similar to a nested loop. But you might ask me, you can't give it like this. No, you can't give them together, because that will require a nested thing here. But since this is not nested, what can we do? This can be simplified. Range of 3, comma, range of 3. Is it possible? Nope, not at all. Why? Because not how you use it. If you have something like a nested tuple like 1, 2, comma, 3, 4, then it could be possible. But it's preferred you don't use something like this, or even complicated things like for x, comma, y while writing list comprehensions. It could be just a one-liner, but in code writing, readability is very important. So instead of writing complex list comprehensions, it's way easier for you to write x in range 3, and the same thing again here, like for y in range 3, print x comma y, because code readability is super important. So don't write very complex list comprehensions here. So that must be noted for list comprehension. Only if something is so simple, like printing x for x in this list to print all of them again. But something like that, use list comprehension, and make sure the code is readable and your list comprehension is only used when it's easy to understand. Another thing to note about list comprehension is it's more faster than the for loops. So using list comprehension is faster than for loops because it has something to do with the Python's internal code. So which makes list comprehension faster than the traditional for loops. But instead of speed, it's more preferred to have it in for loops as long as readability is massive concern. So before we come to these rest of them, let's learn these four. So what is lambda? Lambda is a function. Let's take a variable, and there you have our lambda, x comma y colon x plus y. So in this x and y, this side of the semicolon is, this side of the colon is input, and this side is the output. So it takes inputs from here and gives you the output. So how do you call this? You don't just call the C. It just gives you a function main lambda x comma y. You put parentheses and specify the two numbers. There's taken x as 3, y as 4, and you get 3 plus 4. If it's an 8, 8 plus 4. But make sure these two are, let's just take this out here. Our number of inputs must match the outputs. So if I give something like this and I run this, you get z is not defined. But I put here, it doesn't, because given the positional arguments. But now it adds 8 plus 4 plus 7. This needn't just be addition. You can have x minus y. Okay, I didn't run it, so and now 8 minus 4, you can have star, this multiplication, exponents, so this would be 8 to the power 4, division, it's all possible. And what would be the type? It's a float. So, but 8 multiplied by 4 and all gives you an integer. Division gives you a float number. And what else can you do with it? For example, we can even have flooring. This is an integer. It is rounded up the decimal point. And apart from just adding, we can also have something like conditions. And I thought of an interesting case. Can you take x plus x? So it just does 8 plus 8 here. So you can just repeat the numbers, have a single element, and this can be done. If you want to square up an element, let's make it more meaningful here. Square 10, 100. So that's how you can even use a single element. Apart from just using this in Lambda, you can have this if x greater than 10, else. No, no. What if it's 11 here? I get the square. Or else I can give 0. 9, 0. So else puts in anything. So anything less than 10, according to this condition, will put the else block. But if it's greater than 10, you get the square. So it's good for a secret number, something like if your value of x is 110, so only if the user types in 110, will he get the answer. If he even gives 9, no. Only if I give 110 will I get the mystery answer. Let's try it out with your own creativity. And that was the thing in Lambda. We can also use it in our list comprehension. Not necessarily the list comprehension like this, but x star star 2 for I in 10. Okay, my bad. The names should be the same. So A, this gives you squares of all the numbers from 0 to 9. You want till 10, give 11. From 0 to 10, all the numbers are squared up. So that is also list comprehension. And we are directly invoking it here. It's not same as this, but it's somewhat similar. So coming on to, but before filter, let's go on to map. So what is map? Map is these 3 words, parentheses, and you need a function and you need a list. So our function in the first case would be our lambda. There are also something called Python functions. So when we learn Python functions, we will use the Python function. So we will have lambda functions here, since we know what that is. But x is x, so it's just x is x. And I give here a range of 10. It could be a list. So this thing will return map and the address at where it is, but we need it in a readable format, so it must always be converted to a list. That's the only thing with map, so you need to convert it to something after calling the map function. So without the list or tuple, let's see a tuple, say you won't get the output. So list of map f, the function along with the range. Now I want squares. Star star 2, and I get squares still 9 from 0 to 9. So that is how you use map. Instead of that, we have learned some interesting functions like, let me take, so it should be something like a nested list 1, 2, and 3, 4, 5. This might be hard to read, so let's define it with a variable. And I give here a, close the brackets properly, and I give the sum function. So as you can see, this map, what it does is it applies the function for individual elements of the list. we have also seen for this case for exponents or squaring, in which it applied the squares for each element in our list. In the same way, it will apply the sum function for each element. Since it's a nested list, this is a single element and sum of this much is 3, sum of this is 12. In the same way, we can even have length. So it gives you the length of this 2, length of this 3. So that's how you can use the functions we have learned in map, and make sure the list function is also there, or you will get the memory address. So are we done with maps? Yes. But there is also another thing which might be a little complex to understand, but if you understand it, it's super simple. So let's take a list of map of, remember we can also assign it a variable, and let's give a lambda function of x comma y is x plus 1. These can be any names and a comma b. So this part right here refers to this side, and this part right here refers to the function. So if you run this and print C, you get 1 plus 4, 2 plus 5, 3 plus 6. Also, as we have seen here, even if you give a smaller one, it will only go up till here, and star y, it just multiplies 4 into 1, 2 into 5. So what this does is this function right here takes a as x, b as y. So when this function is running for each element, so in the first one, in this one, a of 0 is taken, b of 0 is taken. So then x gets a of 0, y gets b of 0. It does this into this and gives you this into this and gives you this. So that's how you can even perform like concatenation, multiplication, or any combined operation with two strings or lists like this. So that also must be noted, and make sure you remember it. It could have really good use cases, like you want to add two matrices. So if you want to add them instead of just adding them, and you can just directly put in a function and you can perform an operation for both of them. And when it comes to also Python functions, you don't have to give something big as this. So should I give an example? You might learn, I'll teach you later. So if it's just an add function, so that's how you define the function. And inside that, you give all the things, all the operations you need to make that function perform. And you just have to put the function name here. So just this small thing with this whole thing can easily do this whole operation and give you the same result. So same as Simon. This wouldn't work here because it can only take single element. Two of them won't work. So similar to Lambda, we can even have a Python function, which we'll learn on later. So that's all with map. If we're going to filter and reduce, let's take some interesting cases in map and Lambda. So let's start with simple example of how can you strip this thing right here. It's going to be HELLO. Now you're given the problem of removing, let's even put a white space here, not necessary, both works. So you're given the problem of removing all the white spaces and printing this text. So what would you do in this case? If I do string dot strip, it strips from the left and right. What about this? Can you remove white spaces? There might be other ways of just taking the number letter by letter, but the most efficient and better way I would say would be stripped string. This is just a variable name. Is equal to map a list of map of. We need a function lambda. X is if x in taking just stripping out will directly strip and right. So this is our new list here. So let's just take this list and give it something called, I'm pretty sure you have learned something called dot join in our strings. The dot join, and there you have it. Hello. So an explanation would be required, I suppose. So we have, wait a second, let that load. Let me tell you something. So we have HELLO. So what this does is, so we have HELLO. So when we give X is X dot string. First of all, it takes how many others? 0. Now we even give a space here. So this, 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 this. When white spaces are counted as characters, so these many are there. So when we strip, in the first case, this empty white space is our first X value. When we strip a white space, it returns an empty string. When we strip this, it returns H. This gives you an empty string. And this E right here gives you just the E. And it does this, and you get our stripped string. As you can see, the white space becomes an empty string. And what join does is, as we have learned earlier, it joins everything. So since there is no space and it's just an empty string, when you join them, it just disappears and HELLO will be combined. This can be done for anything, almost like everything could be joined. See, this could be joined even if there are tons of space between letters. You can join them pretty easily and see all the spaces will become empty strings. So that's how you can join them. Another interesting case is something to do with vowels. So let's take another string, string 1. And this will be hello apple. Now what I want to do is I want to take this E right here, O, this A, because they are vowels, and convert them into something else. So converted is equal to list map of lambda. So our variable here can be anything like x. And the thing is, if x in, if x in a e i o u. So what happens if x is in a e i o u? It will be a star, else it's going to be x. And let's specify our string 1. And our converter here will give you a list. And we'll have to join it. Dot join like this. And all the vowels here, E, O, A, E, they're converted to whatever we specify here. If I specify a 0, it'll have 0 here. So, or just take them out. All the vowels are removed from your string. Isn't that interesting? Also, you can count the number of vowels. So it will be 0 if x is in A, E, I, O, U. I mean, it should be 1 because we're counting the number of vowels, and 0. If we're counting the number of consonants, you can make this a 0, this is 1. Run it. We don't count the join. Let's see our list. So here, with all the vowels, you get 1. If it's not a vowel, if it's not in this, we get 0. And we have already learned the sum function, right? Is it like this? Not at all. You have this. Get 4. So E, O, A, E. So those are the 4 vowels, or something better. Dot count of 1. How many ones are there? 4 ones. How many vowels are there? 4 vowels. So that is how you can use strings, lambda and map in some interesting cases. And now let's also deal with something interesting with dictionaries, map, and lambda. So let's have a dictionary here, which has name is Alice. Okay, and age would be 34. That's a dictionary with 2 keys and 2 values, so 2 key value pairs. And let's take something like the new name must be uppercase. This is what we are going to do here is we're going to convert all the key values to capital letters, all uppercase. So let's have map of lambda, where x is, let's give the thing first. So this dictionary might be too big to type in. So info dot items. That's great. So after info dot item, what does this give you? Info dot items. It gives you, let's print it out. So it gives you a list with 2 tuples inside. So this right here must be same as this. So let's have our braces, and this, the first thing right here, this one, the name is x of 0. And second one right here is x of 1. So you can apply your own functions to these. So I give you dot upper and then uppercase, have to convert it to dictionary. Say the name is in uppercase. Only the keys are in uppercase. And this is as it is because we did nothing with this. Another example would be, let's take num is a dictionary of A is 1, B is 2. Also take C. C is 3. And then just copy paste it. It's the same code, and num C is dot items. And for the first one, let's do a title case, and this one, let's multiply each of them. Note that all the value pairs are of the same data type, but if you do into 2 here, num C converted to a dictionary, you get A as title case. In title case, all the first letters are capitalized here because A is the only one here. So, and this one right here, it's multiplied by 2 for each. But if I give here another A, S, D, F, would this be possible? Sure. What does it do? This is multiplication or repetition on strings. We have learned something like if you take a string into 5, it repeats 5 times. So it does the same thing here. So that's how you can apply different function for each key and value pairs. So x of 0 is to modify all the keys. X of 1 is to modify all the values. I hope that was helpful in this section, and let's start with reduce. And before going to that, let's show you something interesting or a trick or something which can be helpful, really helpful. You tap FR and give a tab space, press the tab button, you get these. So you can choose this, or with FR there is frozen set. So if you don't know what something could do, you can type in A and you get all the things that can come with A in this. So suppose I need this dictionary command, but I don't know how to write the dictionary class. So I just type this dict. If I want the list class, here's the list. Or I just type L and I could find the list here. Len, license, all the things with L will be noted here. So if you are stuck somewhere without knowing, for example, Lambda, you can just type this and you'll get to know what it is. And apart from that, if I have something like Lambda and okay, that's it, I guess. There was also a way in which you could have, you can even get the inside functions which could be used. All of this. And so here we don't specify anything, but yeah, it will be useful. And instead of just a space, if I give something like a shift and a tab, yes, that was what I was looking for. You get a small documentation right here. So dictionary, self, see, all these arguments can be given in dictionary. And here is a small documentation. So if you're not sure what this can do, just give shift plus tab and you get this small documentation for each and everything. If I take the list, I get this right here. Okay. And so let's take our reduce here. From function tools, you can even get function tools like this. Import, say you can import these two things from function tools. We want reduce, easy peasy. And run this once every time. Like if you run it once, you can use reduce how many times you want. Let's have a list. Instead of that, let's take the list, range of 5. And then this is our list from 0 to 4. Remember the 5 won't be included. And then let's take a random variable name and make sure let's have it meaningful. Reduced. Always when you're writing variable names, make sure if you're writing it professionally or for some code, make sure they have a meaning. They are meaningful. So suppose you're taking a collection of numbers or collection of prime numbers, you need to mention the variable as prime underscore numbers or prime, something like that. You should not give something like A, B, C, D. This is just for the tutorials, but if you're writing it professionally or writing code in company and all, you need to make sure the variables are named properly. Radius of lambda space x comma y. We are not having two lists or something, but we give x comma y, x plus y, comma, our list will come here. Now, if you go to reduced, you get 10. So what it does is it does x plus y for each two elements. It takes 0, 1, adds them, then 0 plus 1 is 1, so it takes that one with 2 and adds them. It takes their sum and adds them with 3. Though the sum of these 3 then gets with this 4 and you get 10. So x comma y refer to two elements, so it keeps on reducing it till a single number. So I can even perform multiplication and it multiplies all the numbers because 0 is there, your result is 0. So that's what the reduce function does. And apart from these multiplication, you can even start from a different number. If I take the plus and I give a starting number of 100, it starts from 100. This is the initialization value and it adds it. So you get 110 instead. If I give here 10, you get 20. And another usage would be, suppose your interviewer gives you some random list of hello space world, and now you're asked to join them into a single string. Of course, you would do dot join of random list and you get this. Or you would just, yeah, you could do this. So what if the interviewer says you can't just join it like this? It doesn't want you to use the join function. So instead, what you could do is you could use the reduce, and reduced would be, this is any variable name. This is not something compulsorily, or you can name it anything, and reduce of lambda. Make sure lambda is given x comma y and x plus y. So since if you have two lists and you combine them, you might now get a string. So x plus y, and let me show you what I meant. And if I press and reduced, I get this right here. Note that I don't get a list of these combined, but I get type of string here. And another thing to be noted is if I have, let's take this num list, I add random list plus num list, not num list plus num, I get concatenation. But here, if I give plus, it's not addition of the list, but a plus o, a bomb. This is what's being done here. And it won't give you in a list, and it's just a string, not a list. Not a string in a list, but just a string. So that is the reduce function or the reduce class. And let's move on to filter. So we can even use filter to filter the list and even flatten the list. Okay, so with the filter, what we can do is, and before getting into filter, let me show you one thing. So you have heard of range function like this. So num is equal to list of range of 10. And this is your num. What if I give here a tuple? I get a tuple. If I give here a set, I get a set. So remember, you can even do it for set, range, list, tuple, etc. And then coming on the filter, I've just copy pasted. I'll copy paste a set of topics I'll deal in this thing. So first one is odd even filtering. So you can use a list or a tuple or even a set. Let's take a list first. 6. So this is our list till 6. And let's take our filter one, which is the filter. As you can see, filter function. It's a function word, so don't use this. Is filter of lambda. So it's like this. So here you have the function. Here you have the thing on which the function is being applied. So lambda x is x percentage 2. This means this gives you the remainder of x when it's divided by 2. So if you do 3 by 2, the remainder is 1. 5 by 2, the remainder is 1. 4 by 2, the remainder would be a 0. So let's take the 0 case and let's do it on our list 1. And our filter 1 would be, this is the memory address similar to map. So you can convert it to a list or set, whatever you want. Since it filters whichever gives equal to 1, equal to 0, I mean, you get 2, 4, and 6, which are the even numbers. And if I give equal to 1, I get all the odd numbers. Instead of giving equal to 1, you can also give not equal to, and you get all the odd numbers. And that's how you filter based on odd or even. And this right here could be a tuple, Let's do it for a set in which set has 1, 2, 3, 4, 4, 5, 6, 7. And let's state, don't run this, in set of 1. And as you can see, all the odd numbers are out here. And here is the even numbers of this set. And I have written 4 multiple times, but since it's a set, all the repeating digits are removed and there's only 1 for existing. And this could be also converted to a set. But why do we get this? Because I accidentally assigned this to a set. So can we delete the set? That's great. So I didn't run it. And here you have it. This is your new set. So remember, if you assign any function that's important to you, like assign some filter here, just make sure you delete it. So here is your set. Now coming on to remove empty string, let's take a list which is I, an empty string, hello, an empty string. So we don't want this. We don't want this right here. So what we do is filter 2, which is filter of lambda. This is similar to this. So it's something common in all the filter functions. So x where we want x where x is not equal to an empty set, and it should be done for list 1. And now if you take filter 2, we need to convert it to list 1, and all the empty strings are removed from this. So that is another use of this filter. Okay, now going on to keep only digits. So we have our list right here, which has some letters, some number strings, some letters with numbers, and this, let's have more. And there you have it. This right here is our list, and you can even use the for loop like this thing, or not this one. I mean, this thing can also be done using for loop. Even this can be done in for loop. But let me show you the difference between filter, doing this, and a for loop. We'll see how small this is compared to this. For num in list 2, if num dot is digit, this means if this thing is a digit, if a string only has numbers. If it's a digit, what will we do? We will put them in a new list. List 3 is equal to list 3 dot append. Append is used to add elements to a list, and list 3. But here it's all added in here. Why would that happen? So put this right here and you get all your numbers, because difference. Let me actually show you something. Is num. See, num gives you the last one. So num is a string right now. Dot is digit. If tab it, you see it needs to have this. But what does this give? This gives you the function. So put this, it gives you a true value. But this right here gave a function address. So it takes true for everything. So just missing this right here would make everything here true. But putting this right here would give you the right answer. My mistake also, I suppose. Yes, it's my mistake. I should have noticed. And there's your refined list here. And also, how can you do this same thing in a filter lambda? If we do filter, this would be a third one. Filter of lambda, where x is x dot is digit. The big of this, let's see. And here we have list. This is our list, so list 2. And it converted to a list. And you can see these. But let's see with this. As we have seen in the mistake before, you need these. So that's what this thing does. Filter is just one line with converting to a list, but the for loop is a little bit big to write in code. And make sure you use these things like filter, lambda for simple things like this. Don't use it for complex things. If it's something complex and not easily understandable, make sure you write it in the for loop. So ending topics are flatten list, filter list, enumerate. We have done enumerate, and filter list is this thing right here. And flatten list, set comprehension in dictionary, comprehension is left. So let's do the flatten list. So this is a new part. I just extended it. So let's take a list. Our list it should be a nested list because we're going to flatten it. Right. This right here is our list. So let's flatten our list where we do, and let's take another name. So flatten is equal to, this might be a little confusing. Let's name it properly for sublist. So this is your list and this is your sublist inside. So item for sublist in A or item in sublist. So now we have a single list. So what happens here is, first we start from this. So this is like taking the sublist. So it's better to start from here, I guess. From the first for loop from the left side. So for sublist in A. So this sublist in A means for each element in A. So that gives you this one and this one and this one. So for sublist in A, let's make it our for loop. Print sublist. See, you get this, this, this. And now we are doing for item in sublist. Print item. That is this thing right here. This is a for loop and the next for loop there. So you get these numbers. And when we put them between the square brackets, all of these numbers, they are made into a list. So instead of using list comprehension, the for loop type would be list one would be empty, and it's just list one dot append of item, and this is your list one. So the same thing is done here. It's one for loop and another. So I hope it's understood, and let's move on to set comprehension. So coming on to sets, how are sets made? We have set is equal to, let's take curly braces. Now for the comprehension, we have x for x in range 10. This one right here gives you a set from 0 to 9. We can perform all the things we want here, like x into 2, which gives you all the elements of range 0 to 9 multiplied by 2. 1 the squares. All are squared right now because this is to the power 2. The cubes, no, this is not the cubes. You need 2 of them, yes, and this gives you all the cubes. And this is set comprehension. And other thing you can do with this is, let's take a string, which is apple in the jug, and set one. Now you're asked to get all the vowels out of this. All the vowels. There are many ways to do this, but one way in which you can do is by set comprehension. So x for x in string, if condition, if we have learned this in list comprehension. So if it's just an if condition, it comes here, if x in a, e, I, o, u. And our set to, see, there's no o at this, but there is a, there is e, there is I, and there is u in this. So you get set of all the vowels which are present and only ones. So even if there is aplia, just another extra a, you get a single a in this. So all the vowels which are present won't be shown as many times as they are present, but a single time, because it's a set and you can't have repeating values. So a, e, I, u are the vowels in this sentence. So that is about set comprehension. Dictionary comprehension is so damn similar to this, but a minute difference. So dictionary 1 is equal to curly braces x, but here we have colon to separate the key and the value, x into 2, something like this, where x in range 10, and dictionary 1, my bad, dictionary 1 gives the value, this is the key, and whatever is the value would be the value multiplied by 2. As you can see, this right here gives us the square. So if you have dictionary 1 of 9, you get the square of 9 as the answer. So you can have anything here in here like x plus 2. So for each number in whatever range, you get something else. Okay, so that's another interesting case. So here if I give 8, see 8 has this thing right here, 30. So this can easily convert a single number to another value using this formula right here. This is the value and this is your key. So this can be used in making some secret codes or something like that. Experiment it with your own creativity. And I'll leave it at that. And we are done with this.